Hello guys, this is Code and Code and this is the 12th lecture of this graph theory series part 1, and in this lecture we are going to study about articulation points or cut vertices and the relation of articulation points with bridges. Since we have studied bridges in the previous lecture, so we have knowledge about that and how to calculate bridges. So the definition of articulation point is an articulation point or cut vertex is a vertex which when removed makes the graph disconnected, or more precisely it increases the number of connected components. If you see the definition of cut edges and cut vertices matches at certain level. Bridges have the same definition as when you remove the bridges the graph gets disconnected, or the number of connected component increases in the graph. Same is true for articulation point. When you remove an articulation point, when you remove a vertex from a graph, you also remove all of the incident edges, all of the edges that are incident on that node. So when you remove an edge, when you remove a vertex, and if the graph gets disconnected or the number of connected components increase, then the cut vertex then the vertex is known as cut vertex or articulation point. In the current graph you can see there are two nodes which are marked red. These two nodes are articulation points. If you remove any of the vertices marked as red, then the graph would get disconnected. For example, if I remove the first red node, this red node, then all of these three edges would also get removed. In that case, we would have two different connected components. First one is this and the second one is this. So we see the total number of connected components have increased. So this node is actually a cut vertex or articulation point. Same goes for this. Now we would study the relation between articulation points and the bridges. For this graph, how many bridges are there? If we look closely, we know that there are two bridges, and those two bridges are these two, which are marked as red. If you remove any of the bridges, then the graph would get disconnected. Now for the same graph, what are the articulation points? If you see, these are the articulation points which are marked as red. Now, can you define or can you see any relation between articulation points and bridges? Well, there is one relation, one observation we can make, and that is an endpoint of a bridge is actually an articulation point. As you can see, these two are endpoints of this bridge and these two are ends of this bridge. So is it true that any endpoint of a bridge is articulation point? If this is true, then we can use the same algorithm that we use to find bridges. Using that same algorithm, whenever we find a bridge, what we can do, we can insert both of the endpoint into a set so that we have unique vertices which are actually cut vertices. Before answering the question whether endpoints of a bridge are cut vertices, let's answer another question: why these nodes, the endpoint of these bridges, are actually cut vertices? The reason is, see, when we know when this is a bridge, that means if you remove this edge, the graph would get disconnected. And these two endpoints, when you remove any of the vertices, what would happen when you remove, just a second. So when you remove this vertex or this vertex, what would happen? If you remove this vertex, all of the edges which are connected to this node would get deleted, and we know if this edge gets deleted, the graph gets disconnected, and when the graph gets disconnected, the vertex which was removed is known as will be called cut vertex. So when you remove this vertex, this edge will get removed, and when this edge will get removed, the graph becomes disconnected, and hence that is why this vertex or the endpoint of a bridge is actually a cut vertex. So that is the reason why the endpoint of a bridge is actually a cut vertex, because when you remove that node, the bridge also gets removed, and we know when we remove a bridge, the graph gets disconnected. That means this vertex acts as a cut vertex. But again, now on the same question, is it always true that all the endpoints of a bridge are cut vertex? For that, let's see another example. Let's see this weird looking graph. In this graph, what are the bridges? We see the edge marked red is actually a bridge. And what are the articulation points of this graph? If you see, the articulation point is only this node, not this. So this is enough to say that not all the endpoints of a bridge are articulation points. Now see why this is not an articulation point. See, when you remove this node, the graph is still connected. See, even though this edge has removed, when we only remove this edge, what happens? We get two connected components. One was this and one was this. But at this in this case, what is happening? When you remove this vertex, you are removing this edge but also removing this vertex, so the graph is still connected. So okay, we can improve our observation, and the new observation would be, for a bridge, its endpoint, whatever endpoint is having degree more than 1 is actually an articulation point, and that is very true. This node was having a degree 1, so when you remove this node, only there would be one disconnected component. 1 means the only connected component, but for this node the degree is more than 1. So what would happen when you remove this node, this and this, there would be two disconnected components, so that is why this node is still the articulation point. So whenever you find a bridge, you have to look for its degree of the endpoints. If the degree is 1, then of course that node cannot be a articulation point, otherwise the node is articulation point. But are the only nodes which are connected to bridges, are those the only nodes which are cut vertices? Well, it turns out that the cut vertex can exist without the existence of bridges. For example, this graph. If you see, there are no bridges in this graph, but still there exists an articulation point. See, so the observation that we have made have led us to this conclusion. So whenever you find a bridge, whenever we see a bridge, the endpoints of the bridge can or may not be articulation points, depending upon the fact that whether the degree is greater than equal to 2 or not. If the degree is at least 2, then the endpoint, whatever endpoint is having degree at least 2, that point is articulation point. Second, it is not necessary for the articulation point to be an end of a bridge, as we have seen in just previous example. So finding algorithm for bridges actually cannot be used to find the to find articulation point. This was important to explain before going to explain the algorithm for finding articulation point. The reason is that there is a lot of similarity uh, between articulation point and bridges. That is why it was important for me to explain what is the actual difference and what are the at what extent does there is relation between the cut vertices and cut edges. So this was all for this lecture. In the next lecture, we will study how actually we can use an algorithm as we have seen previously using the DFS tree. We would use the same algorithm and we'll slightly modify that algorithm to find articulation points. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.